Hello, Dr. Esterline again, completing lab for those on quarantine for Chem 103L. This is experiment number 11, buffers and buffer capacity. So let me show you which one I'm talking about. This particular experiment, buffers and buffer capacity. Now we're going to be talking about buffers, and maybe you haven't talked about it in lecture yet, but you can read this page. It talks about it a little bit. We'll come back to this. But let me specifically talk about buffers. A buffer is something that has a weak acid and its conjugate base. Has to have both. So two chemicals present. The conjugate base is a salt, a negative positive charge. So you can draw it in its neutral form as well. It has one acidic proton. In fact, we're going to be working with this one. This is acetic acid. We're going to remove that acidic hydrogen. Acetic acid is found in vinegar. It's a very weak acid. We can add NaOH and remove that hydrogen, and it becomes O negative and A positive. So here's the chemical reaction. CH3CO2H. We're going to add NaOH to it, and it's going to convert this acid by removing that hydrogen, and that OH is going to become water. And what's left behind is just the CH3CO2 negative and A positive. So we're converting acetic acid into sodium acetate. So one more thing about a buffer. A buffer has to be a weak acid. It cannot be strong. So for class, I listed the strong acids here. Make sure when you're answering the post-lab questions that you're not dealing with one of these. Hydrochloric acid, hydrobromic acid, hydroiodic acid, sulfuric acid, nitric acid, chloric acid, perchloric acid. All of these are considered strong acids, and they cannot be used to make a buffer. A buffer has to be a weak acid. So any acid that is not one of these six will work. Okay, so we're going to be working with three buffers. They vary in concentration of the acid, acetic acid, and the sodium acetate. So you can see buffer 1 is 0.1 and 0.18, buffer 2 is 0.3 and 0.55, buffer 3 is 0.5 and 0.91. So the concentration is going up. As the concentration goes up, buffer capacity goes up. So it takes more and more NaOH to convert it into conjugate base, right? And it'll keep reacting. It'll keep converting. NaOH will keep converting acetic acid into sodium acetate until you run out of acetic acid. Then you're going to see excess NaOH suddenly make the pH rise. So I think I forgot to mention the definition of a buffer. A buffer is a solution that contains a weak acid conjugate base pair such that it can neutralize any addition of acid or base. The main definition of buffer is it maintains or minimizes change in pH. It has an acid and a conjugate base that can react with and neutralize any acid or base. It's important in our blood. Our blood pH is 7.4, which is slightly basic. 7.0 is neutral. We have many buffers in our blood, even the carbon dioxide that we exhale. When it builds up, it becomes carbonic acid, combines with water. So buffers are important in living systems. In order for our enzymes in our body to function normally, we have to maintain a certain pH in our blood. Okay, so let's collect data. We have these data tables to fill out. And I have data from students. So you are going to be filling out trial number 1, and then we will get the last trial from student data. Dang, I don't have that page. No, I don't. So you will have trial 1 for comparison. Okay, so now let's go collect the data. We're going to add NaOH to a buffer and measure the pH. So first thing we have to do is grab a flask. So I'm walking over here. I'm going to grab a flask. One of these will work. And I've already pre-measured out buffer number 1. All right, so there's buffer 1, 0.1 molar acetic acid, 0.18 sodium acetate. I've measured out 10 milliliters like the procedure says. I pour that in the flask. And then we walk this over to a station where we have a pH meter. So you can kind of see on the screen here, we have a pH of 10.5. We have a pH probe, and this probe is glass. The glass is porous. It allows hydrogen ions to pass through it, and we're actually measuring the concentration of hydrogen ions, right? pH is the negative log of hydrogen ion concentration. So I put it down in that solution, and you can see as I have the pH probe in the solution, we're at 5.0. So you're going to record 5.00 for 0 milliliters of NaOH. We just have the buffer, 5.00. So now in this burette I filled with 0.1 molar NaOH. And I'm going to add into this flask that has a pH of 5, I'm going to add 1 milliliter. So we are at 5. I'm going to go down to 6. Come on, go. So now we're at 6. We added 1 milliliter. So what you're going to do is you're going to record 1.0 milliliters of NaOH. I put the probe in. I give it a swirl. And we see the pH actually jumped. We're going to say 5.29. So you record 1.0 milliliters of NaOH added. The pH was at 5.0, now it's at 5.29. 5.00, now it's 5.29. So now we're going to add another milliliter. So now you say 1 more milliliter. We measure the pH. .76. Add another milliliter. It's pretty close. Put the probe in here. So you're writing 1 milliliter, 1 milliliter, 1 milliliter down that column, and then recording the pH. So that 1 milliliter changed the pH to 11.37. So the pH started out at 5. It has now jumped past 6. So we were just going up past 6. So we're done. So this last one we added 3 times and we got 11.41. So total, you want to add up the total milliliters down here at the bottom. Okay. So for that particular buffer, it took 3. I'm going to set this aside. I'm going to grab another flask. We're walking over and we're going to add buffer number 2. Here's buffer number 2. Concentrations are higher, 0.3 and 0.55. I got 10 milliliters. I pour it into a clean flask. I walk over to our station, put the pH probe in, and record the pH. Once again, pretty close to 5. This is 5.06. We'll say 5.06. So we're going to keep adding NaOH until it goes up to 6.06. So we're at 8. We're going to 9. Added 1 milliliter. 5.06 goes up to, right, probe is in the solution, 5.12. Set that aside. So we did buffer 1. Now we're on the next page, buffer 2. So our initial reading was, go back and watch the video. I added a milliliter and it went to whatever that was, 5.12. So 1 milliliter, 5.12. I'm going to add another milliliter. And see what it goes up to. Got the probe in. It's at 5.20. So I'm going to add another milliliter. Right, you're writing this down, right? As I add a milliliter, you put 1 milliliter and then you record the pH, 5.30. Add another milliliter. probe is in. 5.42. I forget what our initial number is, so I'm just going to go up to 6 or just past 6. Add another milliliter. Check the pH. So of course, students took a lot longer to do this than me. 5.57. This is a rough and dirty lab. Add a milliliter. So I'm getting it close to a milliliter. It does not have to be exact. I put the probe in. 5.74. Keep going. We're almost to 6. Add another milliliter. I'm not sure if that, there it is. Put the probe in, give it a swirl. There we go, 6.04. And just in case that's not quite 1, I think we started out somewhere near 5 point something. I'm gonna add 1 more milliliter, and this should jump dramatically since it's now changing. May not need this milliliter, right? We are only raising the pH by 1. Definitely past 1. Yeah, see, now it's starting to dramatically change. We're at 7 point. Yeah, so it starts to get unstable. The pH does as we get out of the buffer range. So we're at, I'm just going to say 7.23. 7.23. So we're done with the second solution. So we'll set that one aside, the second buffer. We're grabbing another clean flask. I got the third buffer here, 0.5 and 0.91 acetic acid, sodium acetate. Got 10 milliliters of it. Pour it into the flask. Go over and read the pH. Put the probe in here. Give it a swirl. The pH, notice they all start out pretty much the same. 5.06. So now I set the probe down. Add a milliliter of NaOH. So 5.06 I think it was. So I added a milliliter. Put the probe in. Actually, sorry, with this one, we're going to do 2 milliliters at a time. That's what I had my students do. So we're not adding 1. This one takes longer, so we're adding it 2 at a time. So go down to 18. Come on, there we go. Yep, 18. And our pH is, so it was 5.06, now it's 5.14. Okay, 5.13. Added 2 milliliters. So you're adding for buffer 3, 2 milliliters, 5.13. Now we're gonna add 2 more. So every time we add, you're gonna say 2 milliliters. So there's 1, there's 2. Since I'm not being that careful, you can just use 2 significant figures, 2.0 milliliters, 5.22. Remember we started at 5.06. I'm saying that to remind myself. Come on, focus. There we go. 1, 2. Added 2 milliliters again. Got the probe in. 5.34. Add 2 more. Close to 2. Put the probe in. 5.50. 5.50. Add 2 more. Notice this one's taking a little longer because it's a more concentrated buffer. 5.65. Remember we started at 5.06, so we got to go up to 6.06. So I'm going to have to move this. Got to set this down a second. Yeah, so I had to move this burette up. Let's see. So we're at 26. We're going 1, 2, right there. probe in. I think that's it. We're going to say 6.06. We're going to call that 6.06. So we're done with buffer 3. So once again, to get data from other students for trial 2, 3, and 4, or actually, if you want, you can just go with the one trial. So we have one more here. This one goes really fast. Water. What happens if we just add water? No buffer, just water. So set that aside. Grab another flask. In this flask, we're going to put 10 milliliters of water. All right, so we're going to assume that's close to 10. I'm going to check the pH. The pH of this 10 milliliters of water is 6. So since there's no buffer in there, it bounces around quite a bit. Probably dissolving things off the probe. Yeah, so we're going to say 5.43. 5.43 is the beginning pH. So we're going to add to this 1 milliliter of NaOH. Actually, I'm just going to do half a milliliter. It only takes a little bit. Half a milliliter of NaOH went in here with our water. All right, so probe is in. It jumped to 10.39. Actually, 10.4. We're going to call it here in a second, 10.43. Actually, it kind of likes 10.42. We'll do 10.42. So we added 1 milliliter of water, and it went to 10.42. What that shows you is the pH dramatically changed. I can't remember the beginning number. It's in the video. It was near 5 something, and it jumped to 10, way up. Okay, so the rest of this is just answering the post-lab questions. Post-lab question 1, 2, 3, 4, 5, 6. So 6 post-lab questions. This lab is due next week. Bring it into lab with you. Ask questions if you don't understand any of the post-lab questions. Next week is the final exam for lab. So look over all your experiments. Figure out what you missed. Ask questions about the things you don't understand. Come prepared to take that final. All right, we are done.